Welcome to the deep dive. Today, we're plunging into something we all do, but maybe don't think about enough: sleep.
Right.
I mean, think about it. We spend roughly a third of our entire lives asleep. A third.
It's a huge chunk of time.
But if I asked you point blank, why do we sleep? Well, the answer is surprisingly tricky. It's still a bit of a mystery, isn't it?
It absolutely is. People have wondered about this for, well, centuries. And,
Yeah.
while we don't have one single neat answer yet,
Yeah.
what's really exciting is the research. Decades of work have given us some incredibly insightful theories, like pieces of a puzzle.
Right.
And when you start putting these pieces together, they offer, I think, really profound insights into why sleep is so vital. It's not just rest.
And that's exactly our mission for this deep dive. We want to unpack the most compelling ideas out there right now about why we sleep. We're drawing on work like the enduring mystery of sleep's purpose.
Mm-hmm.
The goal here is to give you, our listener, a clearer picture, maybe a deeper appreciation for this thing you do every night, often without a second thought.
Absolutely.
So let's start digging into those clues. Okay, so maybe a good place to start is thinking about another really basic drive we have: hunger.
Okay. Yeah.
You get hungry, that feeling makes you go find food, get nutrients. It's this powerful internal signal.
Undeniable.
Have you ever stopped to think how similar that feels to that, overwhelming pull towards sleep when you're really wiped out?
It's a really striking comparison, actually. Both eating and sleeping, they're governed by these incredibly powerful, almost non-negotiable drives inside us.
Right.
You ignore hunger, you get that physical discomfort, that gnawing. You ignore sleepiness, you get that heavy, can't keep your eyes open feeling. It's just intense.
Uh-huh.
And just like eating is the only thing that really satisfies hunger, sleep is the only thing that truly gets rid of that deep sleepiness.
Right.
Our bodies seem to regulate sleep just like they do eating, drinking, even breathing.
So it's that fundamental.
It really suggests it's absolutely critical, not just nice to have, but essential for our health, our well-being.
Okay, that makes sense. And we all know, kind of instinctively, that getting enough sleep makes us feel better, right? More alert, more energy, probably happier too.
Definitely. The subjective feeling is undeniable.
But that feeling, that's just scratching the surface, isn't it? It doesn't really tell us why it's necessary on a, deeper biological level.
Precisely.
So the core question we're digging into isn't just about feeling good afterwards. It's more like, is there one main reason for sleep? Or is it doing lots of different jobs, maybe all connected somehow?
And that's the exact challenge scientists have been wrestling with, coming at it from all sorts of angles.
Like what?
Well, sleep deprivation studies, for instance. Seeing what happens when you prevent humans or animals from sleeping, which can be pretty dramatic.
I bet.
And also looking across the animal kingdom, comparing sleep in fruit flies versus whales versus us, trying to find common threads or evolutionary reasons.
Interesting.
What's really fascinating here is, even though finding that single magic bullet answer has been tough, the research hasn't been a dead end at all. Far from it. We've actually learned so much more about all the different things sleep seems to be doing.
Okay.
It's led to several really promising theories. And the feeling now, the sort of scientific consensus, is that it's probably a combination of these things. Sleep isn't just doing one job, it's likely multitasking.
All right, so if it's likely doing multiple things, where did scientists first start? What's one of the older ideas about why we sleep?
Well, one of the earliest ones is often called the inactivity theory, or sometimes the adaptive theory.
Inactivity.
The basic idea is pretty straightforward, really. It suggests that just being inactive, particularly at night, evolved as a way to survive.
So the logic is stay still, stay quiet when it's dangerous outside, like in the dark with predators around.
Exactly.
Early animals avoided getting hurt or eaten. And that behavior, staying still and quiet, eventually became what we call sleep through natural selection.
That's the core concept. Lying low, saving energy, minimizing risk when being active wasn't very beneficial, and potentially quite dangerous.
Okay, that sounds plausible, but hang on. Wouldn't it actually be safer to stay conscious? Awake and alert, ready to react if a predator does show up?
Mm-hmm.
Being unconscious seems like a pretty big vulnerability, doesn't it? Doesn't that kind of poke a hole in the inactivity idea, if that's the only reason?
That's a really important counterargument, and it's exactly why scientists figured, okay, inactivity might be part of the story, but it can't be the whole picture.
Right.
Sleep must offer something more, some deeper benefit to actually outweigh the obvious risk of being unconscious and vulnerable.
Okay, so if just hiding isn't enough.
Hmm.
What else is a major driver in evolution? You mentioned energy earlier.
Yes, exactly. Energy resources are fundamental, and that leads us straight into the energy conservation theory.
Right.
This one suggests that maybe sleep's main job or primary job is simply to reduce how much energy we use, especially during times when it's not efficient to be out looking for food, like at night for humans.
So it's like
Right.
powering down.
Pretty much. Research shows our metabolism slows down significantly during sleep. In humans, it can drop by about 10%.
Wow.
And in some animals, like bears hibernating, it's way more dramatic. Your body temperature dips, you burn fewer calories. Sleep is basically our built-in energy-saving mode.
Okay.
It lets us conserve resources so we can function better when we are awake, especially thinking back to times when food might have been harder to come by.
That makes a lot of evolutionary sense. Conserve energy when you can.
Yeah.
But, we still have that strong feeling, that intuition, that sleep restores us, like it's fixing things.
Mm-hmm.
Is there actual biological evidence for that? What's going on inside that supports this restorative idea?
Oh, absolutely. The restorative theories have some really solid evidence behind them. Probably the most striking finding
Yeah.
comes from those extreme sleep deprivation studies in animals. Animals completely deprived of sleep, their immune systems totally collapse, they lose all immune function, and sadly, they die within a matter of weeks.
Wow, that's drastic.
It shows just how fundamental sleep is for basic survival systems. And beyond that, think about major repair and growth processes.
Like what?
Muscle growth, fixing tissues that get worn down during the day, making new proteins, releasing growth hormone. A lot of these crucial restorative functions happen mostly or sometimes only while we're asleep.
So skipping sleep is like skipping essential maintenance.
That's a great way to put it, like letting your house fall into disrepair. But it's not just the body, it's also crucial for the brain.
Okay, how so?
Well, while we're awake, our brain cells, our neurons, are constantly firing. They're working hard. And this activity produces byproducts. One key one is called adenosine.
Adenosine.
Think of adenosine as like mental fatigue accumulating. The longer you're awake, the more adenosine builds up in your brain, and that creates sleep pressure, that feeling of getting progressively tired.
Ah, so that's the chemical signal for tiredness.
Largely, yes. And interestingly, that's how caffeine works. It actually blocks the adenosine receptors in your brain so you don't feel as tired. But during sleep, the brain doesn't need blockers. It naturally clears out all that built-up adenosine, so you wake up feeling refreshed because that sleep pressure is gone.
Okay, so it's clearing out the tiredness chemical. What else is the brain doing while we're out?
This is where things get really fascinating, especially with recent discoveries. Scientists found something called the glymphatic system, initially in experiments with animals.
Lymphatic, like the lymphatic system.
Sort of, but specifically for the brain. It's like a sophisticated plumbing system, a network of tiny channels, and its job is to flush out waste products that build up between brain cells during the day.
Waste products. Like what?
Things like neurotoxic proteins. One famous example is beta amyloid.
Wait, beta amyloid, isn't that the protein linked to Alzheimer's disease?
Exactly the one. And here's the crucial part. This glymphatic cleaning system works much, much more efficiently. Some studies suggest almost exclusively during sleep.
No way.
Yeah, it's like your brain waits until you're asleep to run its deep cleaning cycle, flushing out potentially harmful stuff like beta amyloid. It's a huge restorative function.
That's incredible. Okay, so the brain is cleaning house, repairing the body. What about all the information overload? We learn so much every day. Our brains are constantly making connections. Does it ever get too much? Like a computer hard drive filling up?
That's actually a fantastic analogy. And it leads us right to another important theory, the synaptic homeostasis theory.
Synaptic homeostasis. Okay, break that down.
So synapses are the connections between neurons, right, where information is passed. Homeostasis just means keeping things in balance.
Got it.
The theory proposes that as we go through our day, learning things, having experiences, our brain generally strengthens and adds synapses. There's a net increase in synaptic strength.
Makes sense. We're learning.
But if that just kept going day after day, our brains would get overloaded, it would cost too much energy, and it would become, well, computationally inefficient, like your hard drive getting too full and fragmented.
Okay, so sleep fixes that.
That's the idea. Sleep is necessary to sort of renormalize things. It helps to prune back the weaker or less necessary connections while consolidating and strengthening the really important ones. It's like decluttering.
Tidying up the connections.
Exactly. Keeping the important stuff, getting rid of the noise. And studies, again, in experimental animals, have actually visualized synapses shrinking during sleep and expanding during wakefulness, which really supports this idea.
Wow. So sleep is literally helping fine-tune our brain's wiring. Okay, so we've covered cleaning, repairing, energy-saving, decluttering connections. What about building and changing the brain itself? I've heard sleep is linked to brain plasticity.
Yes, the brain plasticity theory. This is another really compelling area, especially with more recent research.
What's the core idea?
It's that sleep is fundamentally linked to the brain's ability to change its structure and organization in response to experience.
Hmm.
That's what brain plasticity is.
And then we see that how?
Most dramatically in babies and young children, infants sleep a ton, like 13, 14 hours a day.
Right.
And a huge chunk of that, maybe half, is in REM sleep, rapid eye movement sleep. That stage seems absolutely critical for brain development, for building the foundational architecture of the brain.
So REM sleep is construction time for the baby brain.
In a way, yes. But plasticity isn't just for kids. The link is very clear in adults, too.
How so?
We see it directly in how sleep, or lack of it, affects learning and memory. When you learn a new skill, whether it's playing piano or learning a language, sleeping on it helps consolidate that learning, making the memory stronger and more stable.
The old sleep on it advice actually has a scientific basis.
It really does. Sleep deprivation messes with your ability to learn new things and to recall things you already learned. So sleep isn't passive. It's an active state where the brain is reorganizing itself, optimizing connections, essentially making itself better for future challenges.
Wow. Okay, so when you pull all these theories together,
Yeah.
inactivity for safety, energy saving, deep body and brain restoration, waste clearance, synaptic pruning, brain plasticity, it's a lot.
It really is.
It seems pretty clear that, like you said, there probably isn't just one reason we sleep. The evidence points towards it doing multiple really important jobs. They all seem kind of interconnected, too.
Exactly. And understanding this complexity, I think, really changes how we view sleep. It's not just downtime or a break from being awake.
Right.
It's this active, incredibly complex, and absolutely essential biological process. Knowing about these functions helps us respect it more, maybe prioritize it more, and appreciate all the benefits it's providing for our health, our minds, our overall functioning.
Yeah, definitely gives you a new appreciation. This raises an important question, though. Thinking about all this, given how much science has uncovered recently, especially about things like the glymphatic system or synaptic homeostasis, things we didn't know about not that long ago.
Right. The pace of discovery has been quite fast.
It makes you wonder, doesn't it? What else might sleep be doing that we haven't even discovered yet? Are there other essential functions, maybe related to deeper aspects of health or aging or even consciousness, that are still hidden within those hours we spend asleep?
It's a fascinating thought.
What other secrets about this fundamental part of our lives are just waiting to be uncovered? Something to think about next time you drift off.